Hello and welcome to another edition of White Papers on Whiteboards. My name is Keith Flaherty and I'm a validation engineer here at Engineered Seal Products. Today we're going to be talking about alignments or misalignments in a radial shaft seal system. So the three main things that we're going to be covering today are dynamic runout or DRO, shaft to bore misalignment or STBM, and angular misalignment. So let's first talk about dynamic runout. So dynamic runout is where the center of the shaft is offset from the true center of rotation. So in this case, if we have a shaft here, instead of it rotating true, we get more of a wobbling effect. We want to try to avoid that. So what causes runout? That can be from manufacturing. That can be from a bent shaft, or it can be from a lack of shaft balance. So what ways do we measure dynamic runout? And in most cases we use a dial indicator, like the one we have here. So we'll place the dial indicator on a flat surface or on the housing, and then we'll place the tip of the indicator on the shaft surface. We'll slowly rotate the shaft and we'll take the reading off the dial indicator. Now it's recommended that runout stays less than 0.25 millimeters. So how can we prevent runout in our system? Well, one way is to make sure your design includes bearings. Bearings are a good way to stabilize the system and make it so the shaft will run true. So if we have bearings near our sealing surface, that'll help limit the amount of runout that the seal will see. Also, we can choose certain seals to help accommodate the runout situation. So if we take a look over here, I have an example of a convoluted lip seal, and this seal is more flexible. And this allows us to basically accommodate dynamic runout, because as the shaft is rotating and wobbling, this seal lip is able to follow that shaft a lot easier than your traditional lip seal. And this is the only one that's a dynamic scenario, so it's critical when increases in speed. So as your runout increases, you're going to have to run at a lower speed. Otherwise, the seal will not be able to follow the shaft as it's wobbling at those higher speeds, and will create little pockets or gaps within the shaft seal interface and will cause a leak. Now if we move on to shaft to bore misalignment, that is an offset from the center of the shaft to the center of your housing. So in this case, you can see the distance here A and distance here B, they're not equal. And so in that case, we're going to have a lot more loading from the seal on this side than we do on the opposite side. So the causes behind this are mainly from manufacturing or from like your assembly tolerances and stack ups. So to measure this, I'll show you here a simulated housing, and then we also use a dial indicator, a little bit different. So the base will be placed on the shaft, and then the dial surface will be placed on the surface of the bore. And then we'll slowly rotate the shaft and let it follow the housing. And once again, we'll take the reading from the dial indicator. Once again, it's recommended to keep the shaft to bore misalignment to below 0.25 millimeters. So how can we prevent shaft to bore misalignment in our system? Well, this is heavily influenced by the actual design and the stack up of your assembly. So you want to keep that in mind when designing your system. Also, we can use certain seals, such as the convoluted lip, that can also help in this scenario. Finally, we'll talk about angular misalignment. Angular misalignment deals with the face of the seal not being perpendicular with the shaft. And so what happens here is that the seal was not installed flush with its housing. So the main cause, like I mentioned, is installation. And in some applications we've seen it's due to either having like a thin or flexible housing in which there's some motion during the application that causes this angular offset. So when we measure angular misalignment, we simply use a caliper and we measure the depth from a known distance, say the face of the housing to the face of the seal. And we'll do that again on the opposite side, and we'll do that probably a couple times around the seal to see what the difference is between the face of the seal on one side to the other. And we can, in an ideal state where this is flush, you'd have a reading of 0. But in some cases where it's installed improperly, then you will see one side is pushed in a little bit more than the other side. So how do we prevent that? Well, we can use installation tools like the one I've drawn over here. Now this installation tool will bottom out on the housing, but you can also have it so it bottoms out on the shaft. And this allows there to be a reference surface or a hard stop that ensures that the seal is perpendicular with that center of rotation. If this isn't an option for you, then we can look into the seal itself and we can use a flanged case design. In this example, there's an extrusion on the case. It points outwards, and when you install this flush, the seal case will hit the face of the housing, and therefore you know that it's also perpendicular with the shaft. So with all of these cases, I guess why is it so important that we look out for misalignment? And the main reason is because the interference of the seal lip is critical to its life. If we have more interference on one side than the other, then that's going to lead to several issues along the way in your system. So an increase in any of these misalignments ultimately leads to an increase in your underlimb temperature. Since you have more interference here, you're going to be generating more heat in this application. Also, with increased interference, you're going to have more contact from the seal on the shaft. And that will generate a higher torque, and ultimately will be consuming more power from the seal. Also, when we have higher interference, then we get premature wear or additional wear. And in cases like shaft-to-bore misalignment, we can see that the wear is eccentric. So we'll have extreme amount of wear on one side, and the opposite side will be hardly any wear on that seal lip at all. So with these factors in consideration, we can ultimately say that as misalignment increases and we get an increase in these parameters, we're going to see a decrease in overall seal life. Thanks again for watching, and if you have any questions, please go to our website, espint.com.